yeah, just go here. This is 5, 3, number 65. They want us to verify that the original function has an inverse, and then use this buddy point idea to find the derivative of the inverse at negative 11. Okay? So first, the way to verify that a function's inverse is a function, that the function has an inverse function, is to show that it is one-to-one, that it passes the horizontal line test. And passing the horizontal line test, being one-to-one, is synonymous with being monotonic. So if a function is only increasing or only decreasing, it'll pass the horizontal line test, and it will have an inverse function. How do you show something only increasing or decreasing? Well, technically, since we're in calculus class, we can do that with a derivative. And if you look at this derivative, and you think about plugging in x values, well, it's x to the fourth and x squared. No matter what x value you plug in, you're going to get out a positive first derivative, which means the function's increasing. So because f is always increasing, it's one-to-one, and its inverse will be a function. When you reflect it over y equals x, the function will still pass the vertical line test. Or the relation will pass the vertical line test, therefore it's a function. Okay? This is just saying, hey, you can totally use the buddy points idea. If I was going to do this with buddy points, I would draw a buddy burrito. If you're in Mrs. Lemke's class and you don't know what a buddy burrito is, shame on you. Okay. For the inverse, the x value they're talking about is negative 11, which means on the original, the x value they're talking, excuse me, the y value they're talking about is negative 11. I need to find the x value on the original that goes with the y value of negative 11. I'm going to do that on my calculator. Okay? So I'm going to type in this function and y equals 11 on my graphing calculator and figure out the x value where they intersect, and I'm going to get an x value of negative 3. That tells me the y value on the inverse is negative 3. Now I have my buddy points. So when I go to do f prime, I'm not going to do f prime of negative 11. I'm going to do f prime of negative 3. I'm going to do f prime of negative 3. I'm going to get 17. Therefore, the derivative of the inverse of negative 11 is 1 over 17. That's that buddy points idea. I'm using this x value on the original to tell me about the derivative of this x value, buddy point, on the inverse. Cool? That concludes. So nice, guys.